In this video, I'm going to show you how to add fractions and mixed numbers. We'll start with the idea that addition is just to combine two things. And if I want to combine these fractions and figure out how much I have, I should first picture a half and 2/3. If I combine these things, I can already see that, well, thirds take up about, that'd be 1/3. 1/3 might be about that much. And 2/3 would cut in, it'd probably fill up this hole a little bit more than all the way. So when I add 1/2 and 2/3, I'm going to expect that my answer is more than one whole. Let's see why. When we add fractions, we know that we need to have a common denominator. To find a common denominator, we need to multiply the fraction by an equivalent fraction. I'm going to multiply this fraction by 3/3, and this fraction by 2/2. That will change the denominator to be 6 in both fractions. 1/2 times 3/3 is 3/6. 2/3 times 2/2 is 4/6. Now when I add these fractions, because the denominators are the same, I can just add the numerators. And since 3 plus 4 is 7, I get 7/6. If you think of what the fraction means, the denominator always tells us how many pieces to split the whole number into. So if I split it into 6, 7/6, well, 1, 2, 3, 4, 5, 6, I'd need a whole another whole split into sixths again, and I'd get one of these. That'd be 7/6. That explains why 7/6 is equal to 1 and 1/6, because I have one whole and one extra sixth. The quick way to convert these fractions is just to divide the numerator by the denominator. So I'm going to divide 7 by 6. Since 6 goes into 7 one time, that will be one whole, and 1 times 6 is 6. The remainder gets used as the numerator of the fraction. So 1 and 1/6 is the answer, and we could calculate it like that. Okay, so let's try another example. This time we'll try to use some different kinds of numbers. Okay, now I'm going to try to add 3/5 and 1 2/3. The first thing I'm going to notice is that I have a fraction here and a mixed number. And that doesn't really change the fact that I have to combine two numbers that contain fractions, and they don't have the same denominator. So I'm going to start by converting the denominators in both these fractions. I notice that 5 and 3, well, 5 and 3 both go into 15. So I could do 5 times 3, in which case I'd have to do 3/3 for this, and 3 times 5. I'm just going to multiply the fraction part of the mixed number. So let's see, 3 times 3 and 5 times 3. Well, the 3/5 will turn into 9/15 plus 1. And again, I was just trying to convert the fraction here. So 2/3 will be 2 times 5 is 10/15. Okay, so now let's see. How could I add these two? Well, since there's not a whole number in front of this fraction, I suppose I could imagine that I have 0 whole to go along with my 9/15. And then because I have, I prefer to add these vertically. So I like to think about it as 0 and 9/15 plus 1 and 10/15. So when we add, we usually start with the smallest place values and work our way to the left. So if I add 9/15 and 10/15, well, that would be 19/15. And 0 plus 1 is 1. But this is strange. I have an improper fraction next to my next to the whole number. I need to simplify this so that I have a proper fraction here. The way I do that is I figure out how many times 15 goes into 19. 15 goes into 19 one time, and there are 4 left over. So this 19/15 is really like 1 and 4/15. Well, if I take this 1 and put it with the wholes, then I'll have 2, and then I would only have 2 and 4/15. So that's the answer to adding these mixed numbers. Okay, let's do one last problem. So to start in this problem, again, I'm going to convert both the fractions to have a common denominator. And if you've noticed, I've been using the denominator from one fraction to multiply the other fraction. I do that because it will always create a common denominator. You can kind of see why. If I multiply this fraction by 7/7, well, the denominator is going to be the answer to 12 times 7. Since I already have a 7 in the denominator of the other fraction, if I multiply this fraction by 12, then the denominator is going to be 12 times 7, or 7 times 12, and so it'll be the same as what I got over here. So I'm converting the fractions, and 2 and 5/7 is going to turn into 5 times 7 is 35 over 84. And 6 times 12, let's see, that is 6 times 12 is 72. And again, 7 times 12 is 84. So now that I'm ready to add the fractions, again, I'm going to turn it into a vertically written addition problem because that's just how I tend to prefer to do addition. I think it's easier to to carry when we're doing addition and the numbers are lined up right below each other. So I'm going to add now 13 and 72/84 to 2 and 35/84. Well, let's see. 72 plus 35, well, I know 72 plus 30 would be 102. Plus 5 is 107. And that's 107/84. And 13 plus 2 is 15. Now to simplify the fraction, again, I have to convert 107/84 back into a proper fraction. So I'm going to think of how many times does 84 go into 107. And I know 84 goes into 107 one times, and then I want to see how much is left over. So I'm going to just subtract these so I don't make a mistake. And let's see, I have to borrow. Okay, so I get 23 that are left over. So that means that 107/84 is going to be 1 and 23/84. So if I take the one whole and add it back into the whole numbers I already had, the 15 whole, I'm going to have 16 and 23/84. And that is my answer to the problem. Okay, so just to recap, when you're adding mixed numbers, just like with fractions, we need common denominators in our fractions. And once we've figured out the common denominators, we should add the fractions. I like to do it vertically. And once we've added the fraction parts and the whole number parts, sometimes we have to think about how we're going to carry if we get an improper fraction. And so we do that by converting the improper fraction back into a mixed number with a proper fraction. And then we add on the whole number to the whole number that we had to begin with. So I hope that helps you add fractions and mixed numbers. And the next video will be about how we can subtract fractions and mixed numbers.